Yeah, well, I was really thinking about what should actually my title be, and I came up with boring factor statistics because statistics are usually boring. So it's a simple. Just to give you a warning, this is a news article that appeared on Monday, so that everybody actually understands what we are doing here. U.S. is dropping bombs. It's not war, but guessing a computer perhaps it is. The U.S. government sure has an interesting way of defining war these days, just a few months after the Obama administration played word games with the public by insisting that airstrikes in Libya were just kinetic military actions and not acts of war. The Pentagon has now come on the record stating that it will treat all acts of cyber hacking against the US as acts of war. So the stage is set for an interesting discussion afterwards. Just an expansion of the crypto laws. Yeah. Well, we did the PasswordsCon in December last year. Don't ask me about the name. That was like the magazine, just passwords. Yeah, there we are. And you will find the archives, both the presentations in MP4 recordings, as well as most of the presentations in PDF formats. It's available at the FTP server of the Institute of Informatics here at the university. And just a couple of weeks ago, we were at a place in Norway called Finse, where there were several really interesting talks in cryptography and information security. And I did also a talk there for like almost 3 hours on passwords. So eventually, if you would be that interested in passwords, you can go online and have a check, look at that presentation as well. And we'll also create Passwords 11 as soon as we are done, more or less today, and put out the new presentations there as well in the next couple of days. So, I want to start with talking about the exception. The exception is that I've been doing now like my own personal password research for at least 10 years now. And this is data based on an Active Directory domain, a Windows domain, from somebody in a galaxy far, far away. I can't say much more than that. And during all the years that I've been doing penetration testing and password cracking and password statistics, this single domain stands out from the rest in many different ways. So I wanted to give you some statistics based on this domain, this company, first. So there are some default Windows parameters that you can normally configure, like minimum length, change frequency, password age, how often can you actually change your password, password history, account logout, reset logon count, and logout duration. And in this domain, at the time that I extracted the data, the minimum password length was 3. Change frequency was 90 days. You had to change your password every 90 days. You could change your password immediately, so just by, oh, I have to change my password, change it, and you can change it again and again and again and again. And one of the war stories that I think I told this one at PasswordsCon as well, is that I actually, a couple of years ago, I went to one of my colleagues who did cloud programming, and I asked him, I got some data that I want to analyze. And what I'm looking for is that in my data I can see the password, and I can see the date and time that the password was changed. And I'm looking for traces saying that, like in January and in February, the password is the same password, but the date and timestamp has been updated. And he looked at me and said, why are you looking for that? Well, because of the password age being set to 0, I'm looking for people that every 60 or 90 days will change their password for they will change it 10 times or 20 times, and then they will just change it back to the password they are always using. And the fun thing is, my colleague turned completely red in his face and said, well, there's at least one who does that. And that was by pure chance, because I didn't know that he was doing that. But he was. every 90 days, he would change his password change it like 10 something times. Then he went back to using the same password as he was using all the time. So there's if passwords are a struggle to you, that's one of the tricks that you could actually use. So password history was 0, meaning that when you were forced to change your password, you could just enter the same password again. You actually didn't have to go through a loop. My password is password, and you have to change your password. Okay, my new password is password. Okay, send the system. Period. Really simple. You had 5 attempts to log on to an account before the account was locked. But after 30 minutes, you would have another 5 attempts to log on. And if you did log out your account, in 30 minutes, it would be automatically it would be opened up again using the account logout policy. The only you also have the disabled parameter that you can set for Windows accounts. But then again, that means that there's an administrator going in and saying that this account is now disabled. But that is something else in this. This is part of the password policy. So this was the policy. Now, also on the written policy side, I should also say that this company didn't have a written security policy. They didn't have a written password policy, and they had never, ever done any kind of security awareness training for their employees whatsoever. And that's important background information for these next slides. Also, looking at the number of accounts, in the Windows domain, there were 632 accounts. Now, this could be humans. This can also be test service accounts, share accounts, and so on. So it doesn't really say much about the number of people in this domain, which is kind of important to me to hide at this moment. Now, for the username equals password, please make a guess.
100.
100? That much? Well, 193. I would say 100 was a pretty wide guess. Yeah, well, it was actually 193. Username equals password. Password never expires parameter. You can set that on your account so you don't have to change your password.
300.
Just 250, actually.
Just the others didn't figure out the option exists.
Well, not everybody was actually the domain administrator, so they couldn't do it, set that parameter onto their own account.
So there were 250 domain administrators?
No, there were not 250 domain admins, but you can share one of them. The typical thing is that service accounts not being used by humans, they will very typically have password never expire set on them. It means less hassle. Now the problem is that service accounts used for doing backups, antivirus control, and so on, those accounts will typically have domain administrator account access, or at least local administrator access to the domain controls and so on. So that those accounts are really, really important to actually protect with good passwords, and they should be changed frequently. Now, one of the things that I'm doing, and this is a little bit country specific, I think, is that I'm also looking at for how long have the password actually been there and haven't been changed. And in Norway, I'm doing usually 14 months, because then we have the option of you could be on fraternity, maturity leave, yeah. And you can in Norway you can go on maturity leave for up to 1 year, and then you can add a little bit of holiday as well. So I'm using 14 months just to have a look at it. And interesting is that 305 accounts out of 632 haven't changed the password for more than 14 months or more. Yeah.
Are these all active accounts? Were any of these disabled, or?
All of them were active accounts. None of them are disabled.
Okay.
Absolutely none of them are disabled. Yeah. Exception number 3. entropy. Letters only in the passwords, or digits only, letters and digits. Let's start with letters. How many passwords do you think only contains letters?
Well, maximum of
409. Only digits, 9. Letters and digits, 201. Letters and specials, 1.
And that's probably the support account that's default.
Something like that, yes. And 3, that actually does letters, digits, and specials. Now, I'm saying letters here because this is based on the non-mon passwords. So we are at uppercase only here. But this is what it looks like. So going back to NIST SP 800-63, which talks about entropy and passwords and stuff. Yeah, well, you have, yep,
How many accounts were there in total? Did you
632. Even more interesting is to look at the password length distribution. Any wild guesses? Starting with 2, 3, 4, 5, 6. How do you think this is going to look like?
Some shorter path,
5 or 6.
fall down.
The minimum length requirement is 3.
Maybe 5 or 6.
Here's one password that consists of 2 letters. There's 21 passwords that are of length 3. There are 10 at length 4. And there are 49 at length 5. And then suddenly, it looks like this.
So how can you have the one length? Is it not enforced?
No, because this is one of the things that I'm really talking about everywhere, is that there are many, many people, or security guys, that does password policies on paper. And they have this thoughts that when they change their password policy or their security policy, they can just publish it on the intranet. And the next day, the entire organization has just automatically changed all the systems to be compliant with the new security policy. Now, you could be on leave here for all kinds of reasons. And when you update the policy, even the technical policy, still it won't apply before you change your password the next time. Eventually, you could say that tomorrow we are changing our password policy, so tomorrow at like 12 noon or something, everybody has to change their password, period. Even if it's just like a couple of minutes since the last time you changed your password.
Yeah, that's not very complicated.
Yeah. And in this again, going back to the 14 months plus age passwords, one of the things that I found in this that was the oldest password hadn't been changed for more than 7 years. And that account actually also had domain administrative access and had password as its password. So getting access was like, even easier than actually freezing down some memory chips. Also, for the exception part there is that this is probably the biggest exception I've ever seen when it comes to looking at the length distribution compared to the minimum requirements. Because in most environments, I would say almost all environments, what I will see usually is that if we have a minimum length, then you will see immediately that most of the accounts will have passwords that are either of minimum length or maybe 1 or 2 characters more in length. While the gap here from 3 to actually go to 6 and 7 is much bigger. Now the reason of this, of course, if you haven't guessed it already, is pretty simple. People are using words, normal words like summer as an example, or winter, or password as a password. Now there are many more words available that are of length 5, 6, 7, 8 characters that are of length 2, 3, 4 that it will become like natural to use as your password. And that's quite an interesting observation because I've never seen this anywhere else. And again, this company had never done any kind of awareness training. They didn't have a written policy. They never tried to impose any kind of security policy onto the users at all. Al?
At what time of year did you do this audit? The question is, of course, if you did it around Christmas time in Norway, I would think that 3 characters length of password would be more popular.
It was in January, February.
Okay,
Yeah.
so it should apply.
Which year?
Why is 3 October?
Because the Norwegian word for Christmas is jul.
Yeah.
3 characters.
3 letters. Yeah.
What was the naming standard for usernames?
I don't think I should go into the details on that one.
I'm asking since
Standard
since you
is the
said
best answer.
you said that there were so many that had their username equal to their password. But did you check for username 01, etc. Those combinations? Is that one of the reasons why you have specific cases instead of characters?
Yeah, well, again, going back to like the number of passwords that consists only of letters and so on, well, yeah, you can probably figure out parts of the username creation policy used. And also, I have done some modifications to this one, but the interesting thing here is that this says top 10 most frequent combinations of 5 characters. And the number 10 combination is 1, 2, 3, 4, 5, which happens to be the second most common password in the entire world, based on the analysis of the RockU password list that you probably know by now. And there were 7 across that analysis, as I told you. There were 9 passwords that consisted only of digits. 7 of them was 1, 2, 3, 4, 5. Which again is also a really big exception because in almost all environments that I have ever done password cracking, and I'm also always talking about organizations and private companies, you won't find passwords that only consists of letters or only of digits. Almost, or I should say, everyone has implemented complexity requirements by default, more or less, on Windows. This again is the exception. So, that was the exception. Now let's have a look at 176.
Yeah. Can I just ask, to whom did you give the presentation of these results?
To the IT director, who was also the head of security, and to an internal auditor, external auditor, and 1 member of the executive staff.
And what were their reactions?
They were wondering if this was any worse than others that I had seen.
Okay, so they didn't care.
Well, I told them that I have never seen anything as crappy as this. And they were like, okay, well, yeah, but I don't think anybody has hacked us before.
Yeah, they didn't care.
Yeah, well, I really have to inform you that you haven't turned on any kind of logging in your Windows domain, so it's kind of difficult to actually say whether you've been hacked or not. But there were no logging at all turned on for the Active Directory at that time. So they are better today, much better. So, looking at 176 humans, one of the things that you can do in Windows, which could be a big problem if somebody actually manages to compromise you, is that if you do turn on the password history parameter, like you can't reuse like your 5 or 10 last passwords, those last passwords that you have been, the previous passwords that you have been using, will then also be stored in the Windows registry. So if you do if you use Kane enable for Windows, then you can say that you not only want the current password hash, but you also want all historical hashes that are stored in the registry. So this is this is then based on a domain where I've been dumping both the current password hash and going back as much as 23 generations back in time. Now that, of course, one of the things that I'm still a little unsure about when it comes to Windows is that Windows has an option on the password age saying that you can't change your password in like, you need to wait for like 1 day or 2 or 3, 4 days maybe. So there's a counter there, and there's a registry entry saying that this password was last set at this date and this time. But I don't know if that information is available for the historical hashes as well. I don't think it is. And I have yet to ask somebody to try to figure it out for me. But I don't think it is. So I can't really tell you if these generations here, if they are actually, they could be like 1, 2, 3, 4 days old, or this could actually be like looking back in time, several years back in time. But again, I can't remember to have ever seen any kind of research or paper describing analysis of password changes over time, looking at specific users or accounts and looking at the password change for generation by generation. Now here's the thing. Our normal assumption is that if you're using password 1 as your password, you would say that, well, that's probably going to be password 2. That would be your next password. And then password 3, password 4, and so on. And my opinion, if you could compromise this kind of data from a Windows Active Directory, if you're able to compromise like the current password, and the current password is password 1, then you would say that, well, the next time I'm going to break in, I will try password 2 as an example. But if you have like a generation, several generations of passwords for a single user, if they then get compromised and they force everybody to change the passwords, you will either have historical information that will make it even more easy for you to figure out what will the next password be, or at least you will have a pattern analysis. So if you could have some idea what kind of password they are using, then you will also know what kind of pattern they will be using to update their password. And of course, adding +1 at the end, like password 1, 2, 3, 4, 5, 6, and so on, is pretty common. Even more common is actually to see a normal word and 2 or 4 digits at the end, not 1 or 3 digits, but 2 or 4, which again would normally be a date, a year, a birth date, or something like that. And nowadays, I would say anywhere, if there's a corporation, if there's an organization with, say, 1,000 or more user accounts, you can just try out summer 11 and summer 2011 with a capital S, rest lowercase, and 11 or 2011 at the end, and you'll get it, period. It could be that easy, yeah?
Maybe a silly question, but if you have this Active Directory access, whatever this means, you get to see the real passwords, not the hashes?
No, I do extract the hashes and then I do password tracking.
All right.
Yeah.
They are not salted, right?
No, that's the fun thing about Windows. No sorting.
Windows passwords are salted. Even the more secure in Vista and 7 where they drop the landman hash.
The MS
Yes.
hash passwords are hashed. They are all sorted.
Yeah.
Yeah, but
But
not really relevant.
the NT hash passwords, you convert it to UCS2-little-endian, which is the character set encoding, which is basically UTF-16. If you take the MD4 of that, and you store it. Yes, the MD4.
Yeah.
Right. And we still haven't eliminated the landman, which is case insensitive and has other problems.
So then again, looking at these 176 humans, I consider that's the distribution of their passwords. And I've been able to crack, well, almost all of them. And here's what I was talking about is that when there is actually one account or one password that actually has length 7, so it's not actually in compliance with the password policy, and most probably that is due to the fact that the password policy has been changed, the password haven't been changed, at least not yet. And as you can see, the majority is actually on at the minimum, more or less, and then we're going downwards on to be a little bit more complex and advanced passwords. But still, length 15, I've been able to crack that. Okay. Yeah.
Were there any passwords that you could not recover just from
On this data set, no. I could crack all of them. Yeah. It took me a couple of days in total, but yeah. Yeah. I like to tell this story. Jan Frederik, that one. My colleague Jan Frederik, I'm playing this little game with some of my colleagues. It's like, can you crack my password? And Thomas also knows this little game. And sometimes I've been checking up on colleagues. They have asked me, and you can't crack this pair. It's one of the passwords I've seen during the years. And one of the things, I did crack Jan Fredrik's passwords over and over again. And I also told him a little bit on the workings of Windows and the hash algorithms that are being used. And I'm not sure if he actually told me that he had set a new password, but well, I was doing password cracking, and there was one password where the normal hash were not available. So I just knew that most probably the password is 15 characters or longer. And like brute forcing a 15 plus character password is like, it's in a way it's really not feasible. But what I did, I was using a word list that has been created by entering all the words found in the 1,000 largest wikis on the internet, including Wikipedia. So it's like a word list of like 750 megabytes, and that's quite a large collection of words. And I was churning through that and applying 00, 01, 02, 03 up to 99 at the end of each and every word in that word list. And suddenly I found one password. And I'm not sure about the exact length. Maybe it was 32 characters something, 32 or 34. I'm not sure, don't remember exactly. But it was like, whoa, is somebody actually using that? Because it's a phrase from an old television program in Norway, and they had like 99 or something applied at the end. And I just saw it, and I thought, I think I have an idea who this might be. And then I looked up the username, and of course it was Jan Fredrik, and I gave him a call and said, you need to change your password, Jan Fredrik. And he was like, okay, so you did that one as well. Now I don't really know what to do. Okay. Quite fun. Per position entropy, this is also one of the things that I think is pretty cool to have a look at. First, for these passwords, looking at the normal, which is then case insensitive. The number of different characters used per position in the passwords. And you will see that the largest entropy is in position 1, and then we go downwards before we go a little bit up and down again. And this is very typical. Position 1 and position 7 and 8 will usually have the highest entropy, the highest number of different characters used in that position in the password. While going out to like position 11, 12, 13, 14, then you will usually see just digits, and then the entropy is really dropping down. Now this is the case insensitive graph. And if we do make it case sensitive, it looks like this. Pretty much the same. You can see easily that high entropy, position 1, going down, up again on position 7 and 8. And I have a feeling that every time I do this now, in different domains and so on, this is what you get. And to me, this applies if you're going to brute force an entire key space. This will at least give you some logic on what to try first.
But in this data set, are the majority of the passwords words or variations of words? Because people, if you ask people to make a password, they can take a word or they can make a sentence, so that there are different techniques. And you know, most people, if they're given the choice, will just take a word and a number or something somewhere, I guess. But that has, because if it is words, then you would have consonants, vowel, consonants, which would be more or less that pattern. Now only 9 vowels.
I would say that most of the passwords are words. And then again, on my personal blog, I did a blog post on what's a word list. Yeah, the name of the blog post is what's a word list. And a word list could, I called the Norwegian government and asked them, what's a word list? And they said, well, that would be a norsk bokmål, eller nynorsk ordliste, eventually also in Sami language. That's a word list. Words that we use in our language, period. That's a word list. Now, to us as password hackers or crackers or whatever we are, security professionals, a word list, of course, is something much bigger. It could be all kinds of variations of words with digits applied, special characters applied in the beginning, in the middle, in the end, and so on. But I would say for most parts that people will be using words or names and then digits or some kind of special characters applied at the end. One of the funny observations is that it's very hard to find anybody who starts the password with digits or special characters. That is very, very rare. Everybody applies digits, or let's say the complexity part of the password is usually applied at the end of the password.
The other question was, have you done the same analysis on, say, Norwegian list of words, just, or any natural language? Would it look the same for up to 10 character words?
No, I haven't done that. And just going back to Finse, both Professor Tor Helleseth and also from Gjøvik and University in Stavanger, they asked me if I would be interested in supervising like a master's student or something, because I have like way more ideas on how to do analysis. First of all, I can't do any kind of programming at all. I don't know Perl, I don't know anything. I can barely do a batch script in MS-DOS long time ago. So I got all these ideas, but I need help from somebody else to, do the analysis. I'm interested in talking to psychologists on how people are making patterns in the brain. I would like to talk to anthropologists who also talk about social behavior and how we do things in our normal life. I'm interested in looking at the distribution of, let's say, positive words used in passwords, like summer. That's a positive word for most of us, but at least for me, winter is a negative word. So just looking at passwords to see if they are using positive words or negative words, or let's say just neutral words that doesn't really mean anything to them at all. If that could be done, it could be really cool to do. And also, this one, unique number of characters used in the passwords. So there is actually 1 or 2 passwords that have, even though the password is probably 7 or 8 characters or more in length, there are only 4 distinct characters used in that one. While in most of them, actually, you will see that there are 7 or 8 or 9 different characters used in the password. Yeah?
Could you go back to the previous one? You said something about starting off with a word and then continuing with the digits.
Yeah.
When you write a password that is not compliant with the password policy, you're presented with a text that describes the policy. That policy describes, for instance, it needs to contain normal characters. Then it says something about digits and special characters.
Yeah.
If you were to reverse those to do that presentation, which you can't, might the result be different?
And another topic for master students, no doubt. Yeah.
I think you can change the text of that via GPO, can't you?
Yeah, you can. Yeah. No, not by GPO. You have to actually do some programming also.
Use some other registry action.
Yeah. You can. Yeah. For Windows, you can also do your own password filters. instead of the default password filter. Because one of the really big problems or big challenges of implementing a password policy at the technical level is that you want some kind of sane password policy, but still you want to prevent bad passwords from being used. Now, implementing a decent password policy could sound pretty easy to do, but it's very, very difficult if you are to block or disallow bad passwords from happening, because that is very easy to do, even if you have a really strong password policy. Password 1 isn't really a good password, but it will be compliant with almost all password policies you can find in the entire world.
There have been studies, I remember who it was, maybe it's George Beck, who said how about instead of just having the policy that says the shape of the password, also banning the most popular passwords, having a kind of blacklist of stuff. Do you do that? Is that done in that domain that you're analyzing?
It's not something that's built into
No,
Windows. You have
there
to
are the
special-
default Windows complexity requirements, but there are no blocking of that. I also done a blog post because Twitter is one of those who actually have a block list of passwords that they're not allowed to use. And the list is like 120 passwords or something. And it was actually discovered because you could see it in clear text in the JavaScript on the login page. So the list became public like that. And that list is like, well, it maybe do reflect the passwords used by people on services, but there really is no password policy present at all. But it is nowhere nearby anything that resembles an organizational or public company password policy. Also, again, circumventing that, you could still do a really bad password while still being compliant with the policy of Twitter. So one of the things that I've done also, I've done a blog post suggesting a dynamic blocking scheme for blocking bad passwords from happening. Now, it really won't block bad passwords, but it will prevent lots of users from having the same password. So if somebody do SQL injection against you, as an example, and you do sorting, even with sorting, then you can eventually be able to block lots of users having the same password. Because one of the problems that I see is that help desk, which is there to help you as a user, they are actually the biggest single source for bad passwords. Because if they are to create 100 new accounts for 100 new employees starting on Monday, everybody will be given the same password in most cases. Because that's easy to do. Password formats, and here we are at the case-sensitive versions. Uppercase, lowercase, number of digits, as you want. And here you have the variation, which is not that common, 3 digits, and the much more common again with 4 digits at the end. Also, 4 digits, 2 digits, 4 digits, 4, 1 digit again, which is not so common to see again. And the fun thing here is that based on, well, I've done this kind of statistics for many more accounts and passwords than just 176. I'll get back to that, but the fun thing is that on the Free Rainbow Tables project, where James is one of the head developers, we are now pretty close to finishing a rainbow table set for NTLM. That is a hybrid rainbow table set, which will cover passwords that would include this kind of construction and also this kind of construction.
I checked, it's up to 11.
Up to and including length 11. So it doesn't cover the entire key space, but I guess it will be able to, in even an organizational or corporate environment with complexity requirements enabled, I think that rainbow table set alone will be able to do like 50% or more of the passwords up to and including length 11. And then it gets kind of scary because show me anyone who had a password policy today saying that your password on Windows should be like length 11 or 12 or even longer than that. Most companies are at length 6 and 7, some are at length 8.
My phone powers to 10 after you're going to start being fake, so.
Yeah.
Did
Also-
yours change?
No.
Yeah. Also, and this is again thanks to Jan Fredrik and his excellent pearl coding, I can also get out statistics on when the current password was changed. So you can do heat mapping of it as an example. I'm saying that for these 176 people, like between 9 and 10 in the morning, they will usually change the password. While between 6 and 7, 5, 6, 7, 8 in the evening, they normally don't do any password resets or anything like that.
So where's the guy changing the code for?
Yeah,
That would be me.
and the explanation for this is that, no, that one, yeah. The explanation for this one is that these 176 people are all domain administrators, Windows domain administrators. Yeah, all of them are. Or well, they were at some point in time somewhere in the galaxy, I should say.
We could make IDS rules based on strange people changing passwords in the middle of the night.
As an example, yes, you could. Yeah. Pattern, human behavior. So, I also have this one. It could be interesting to have a look at it if it is, well, the reds or the blondes, or maybe those with black hair or those with not that much. Sure! Or should I say we could look for like a highly subjective approach if it is the beautiful people or the not so beautiful people that have the best passwords. And so I want to do a bit of statistics on that because in some cases I actually have data that enables me to do this. So I can couple passwords to the way you look. So I'm going to do a little bit on that, but time is up, so that will be next time. And of course a little piece of dilbot as well, so the fun thing about statistics. Yeah. Questions?